We will now solve problems using Newton's gravitational law and the concepts of orbital and escape velocities. Let's start with this problem. A 75 kilogram person weighs 735 Newton on the surface of the earth. How far above the surface of the earth would he have to go to lose 10% of his weight? Well, obviously this is related to g, the acceleration due to gravity. Is that right? The value of the acceleration due to gravity at a particular altitude is 10% less than what is on the surface of the earth. We need to find that altitude. A decrease in weight of an object with altitude is caused by the decrease in the value of g, the acceleration due to gravity. G on the surface of the earth is 9.8 meters per second squared and is given by the equation. Can you write down the equation for g on the surface of the earth? We did that in the last class. G equal to gme over re squared, and that is, you know, we can replace the gme by gre squared. Well, if g prime equal to 0.9 g, in other words, we need to find the altitude at which the person will lose 10% of his weight. Where if the person has to lose 10% of his weight, the value of g at that altitude will be 10% less than what we have on the surface of the earth. If g prime is the value of g at that altitude, that g prime will be 0.9 of g on the surface of the earth. Is that right? So g prime, the value of g at an altitude h, which we need to find how far above the surface, will be 90% of the value of g on the surface of the earth. So g prime equal to gme over re plus h all squared. The value of g on the surface of the earth is gme divided by re squared, and the value of g, which we call now g prime, at an altitude h is gme divided by re plus h all squared. And this g prime is 90% of this g. Alright. Let's now replace gme by 9.8 re squared. Is that right? gme is gre squared. So we can replace this gme by 9.8 re squared, and we can use g prime equal to 0.9 g. So there are two things we are going to do here. We will replace this g prime by 0.9 g, and we will replace this gme by the familiar form small g re squared, where small g is 9.8. So 0.9 g equal to gre squared over re plus h all squared. Well, you need now only know the radius of the earth. What is the radius of the earth? You know that value, you need to know it. Well, let's solve here. G from either side will cancel. Divide both sides by g. And then cross multiply. You have re plus h all squared equal to, take this quantity equal to gre squared divided by 0.9. I hope you followed that step. I first cancel the g and then solve for re plus h. Now why? Because we are looking for h. So Re plus H all squared is this GRE squared. No, this G is gone. Re squared over 0.9. And now, therefore, Re plus H is square root of the right side. Square root of Re squared is Re divided by square root of 0.9. Therefore, H equal to Re divided by square root 0.9 minus Re. And now use the value of Re. The radius of the earth is 6.38 times 10 to the 6. Using that value, we get H equal to 3.45 times 10 to the 5 meter. So at this altitude, his weight will be 90% of the weight on the surface of the earth. Okay, I want you to look through these steps, the simplification I did, and make sure you understand those steps. Okay, let's do another problem. If a 1000 kilogram object is projected from the surface of the earth with a velocity of 5 kilometers per second, how high will the object go? Use the standard values of mass of the earth and the radius of the earth. Well, wherever possible, you know, we can replace GME by small g Re squared, thereby eliminate the need for using the mass of the earth. Well, what is this problem asking you to do? You are projecting an object with a velocity of 5 kilometers per second from the surface of the earth. That means when the object is on the surface of the earth, it has a potential energy and a kinetic energy. Tell me, what is the equation for the potential energy of an object on the surface of the earth? It will be negative GREM, negative GMEM over Re. That is the potential energy of an object on the surface of the earth. So this object has that potential energy. It has a kinetic energy because we are giving it this velocity. And now, if it rises to a certain height, we need to find the height. How high will it go? If it rises to a height, when it reaches that height, it will have a potential energy there. How much will that be? Negative GMEM over Re plus H. That will be the potential energy there. And what will be its kinetic energy at that time when it reaches the highest point? When it reaches the highest point, its speed will be 0. So its kinetic energy will be 0. We will find the total energy on the surface of the earth, the total energy at a